Hello, my name is Nigel Bowden. I'd like to welcome you to episode 9 of the Wi-Fi for Beginners podcast. This is a series of podcasts discussing the fundamentals of wireless LAN networking. In each episode, we'll take a look at a different aspect of Wi-Fi to build your understanding and knowledge of wireless LAN networks. Each episode is accompanied by a set of slides describing the topics covered in that episode. Although you don't need to review these slides while listening to the podcast, they might be useful to review the material that we discuss and provide a few visual aids to more fully understand some of the concepts and equipment that's described. All recordings and supporting material can be found at my website, which is wififorbeginners.com. The podcast series is divided into a number of modules. Each module describes a major topic of wireless LAN networking. We're actually into module number 3 now, which is talking about wireless access points in a fair amount of detail. If you want to get to the beginning of this module, you need to go back to episode 7 of the podcast. So episode 7 and 8 are the first two parts of module 3, and this episode number 9 is the final part of module 3, talking about wireless access points. So really, to fully understand the topic, you need to go back to at least previous 2 episodes and review those. Also bear in mind that the topics that we're covering throughout the series build on each other as we move through the series, so it's well worth going right back to episode 1 and listening to each of the episodes sequentially, so you get all of the background information which relates to later episodes and modules. If you are following along with the slides, in the previous episode we actually covered slides number 19 to 26, and we're going to be moving on from slide number 27 today. But just before we start, just a very quick review of what we covered in the last episode, just to get you back up to speed and refresh your memory. So we started at slide number 19, and we were talking about the main AP components, and we were specifically looking at radios, and we discussed the half duplex nature of radios, whereby an AP radio can either be transmitting or receiving at any point in time, but can never be transmitting and receiving at the same time, and this mode of operation is known as half duplex. And this contrasted with Ethernet switch networks, where we can send and receive at the same time, a mode of operation known as full duplex. We also talked about the fact that most APs have at least 2 radios in them, generally one dedicated to the 2.4 GHz band and one to the 5 GHz band, and we also talked about the fact that the 2 radios operate independently of each other, so that each one can be talking to a different client at the same time, but both radios are still subject to the half duplex restrictions we talked about earlier. We also talked about some of the other major components, such as CPUs, memories and custom silicon that we need to perform the amount of processing and provide the features that a wireless access point needs. We talked in a fair amount of detail also about the Ethernet interface of a wireless access point. We talked about the fact that an Ethernet port for access point needs to be at least 1 gigabit in speed, and even this requirement is being surpassed in more recent access points as the 802.11 standard evolves and speeds increase on the client side of things. We may well break the 1 gigabit per second barrier and need higher speeds provided by the new emerging mGig standard. We also mentioned that very often a wireless access point is powered over its Ethernet port using the PoE Power over Ethernet standard. We talked about 2 main PoE standards, 802.3AF and 802.3AT, and generally with modern APs we need to be able to support at least 802.3AT to provide the required power for the access point. And this is a consideration when deploying new switches that we're going to have to support a wireless LAN. We also talked briefly about the console of an access point and how we might use this for initial setup and diagnosis of issues. And then we also covered the main points of considerations for AP installation. I mentioned the fact we wanted to keep them up nice and high in line of sight of clients, we want to avoid putting them near metal objects, behind any sort of obstructions, and near to any known sources of interference. We also mentioned briefly that we need to consider cabling when deploying wireless access points, and we need to keep our cable runs within the 100 meter limit that we need for cabling standards such as Cat5e and Cat6. So now we'll continue our discussion from slide 27. I'm just going to give a very brief mention to the various indicator lamps that you may see on the outside of an access point. Again, in the same way as a console port can be very useful for diagnostics, AP indicator lamps can be very useful, especially when you've got an AP that's mounted up on the ceiling and it's difficult to get to. Just a brief inspection of the indicator lamps can be very useful to give you some idea of the state of the access point. This can include things such as whether the AP is powered on, whether or not the radios are active, whether or not data is being sent and received, whether the AP has entered some sort of state where perhaps it's loading its software, or maybe it's become disconnected from the network. By inspecting the state of the lamps and which lamps are on and off, and maybe their coloration, you can determine what state the AP is in. APs have different numbers of indicators which vary with vendor. They may use different colours, and they may have different flashing sequences depending on whether they're booting or in normal operation. But these are very useful to know when you're providing diagnostics on an access point that has some sort of problems, and realistically you need to check the vendor documentation for your particular access point to understand what the indicator lamps are actually telling you. You also need to bear in mind that in some instances you may actually have a requirement to turn these off. I've been involved in instances in hospitals and schools where the flashing indicators on an access point can actually be seen as a distraction or a disturbance to patients or pupils, and it's not desirable to have them left on. Next, I want to talk a little bit about the configuration of access points. How do we actually configure it, and what do we need to configure on there? Well, most APs will need at least some sort of management IP address to allow us to access it, to set the configuration parameters remotely. And this may include things like accessing a web GUI on the access point, maybe being able to telnet or SSH to the CLI, a command line interface of an access point. It will also be used for communications between an access point and its wireless controller, and also be used by things such as the network management platform, which will be managing controllers and access points. The management IP address is generally assigned by one of two methods. It may be statically assigned using the console port of the access point by logging into the console port and executing a few commands to give it IP address, subnet mask, default gateway, that type of thing. This could be added maybe during the pre-build, if you're doing a pre-build of wireless access points, to get them configured before you hang them around a facility, or more often the IP address will be assigned using DHCP as the access points are mounted. When using DHCP, some access points actually have a number of DHCP options which can be provided from a DHCP server to give information to the access point, such as the IP address of the controller, so that the AP knows where to go, find the controller and get its full config. So once an access point has got its management address and has IP connectivity to a network, there will then be additional configuration parameters which need to be applied to that AP so that it can provide the wireless services that we need from our wireless LAN. This additional configuration may be provided from a number of sources, which are generally vendor specific. The configuration parameters may come from a wireless LAN controller, and this could be a physical wireless LAN controller or a virtual wireless LAN controller that's installed on a customer premises, or it could actually be a cloud-based controller. The configuration may be completed using a web GUI on the access point itself. It could be completed using the CLI, maybe via SSH, or it could be performed from a dedicated management platform talking directly to the access point. Again, this could be a physical on-site appliance, maybe a virtual machine, or it could be a cloud-based management system. The various options which are used are very much vendor specific, but all will provide the same basic function of providing configuration parameters to the access point so that it can fully provide the services that we need around a facility. One of the major configuration items that we need to configure for all of our access points is the Service Set Identifier. You may already have heard of this. It's better known as an SSID, and this is the name of the wireless network or the service that we're providing, and there may actually be a number of SSIDs to provide different services and facilities across a wireless LAN. An SSID, in giving a wireless network a name, allows users to select the network that they actually need to connect to from their client devices. And when configuring our access points, we ensure that the same SSID is used across all access points and is available from all access points across our facility, so that users may remain connected to that SSID and have access to the same service as they roam about a facility, moving from access point to access point as they move between the cells of coverage provided by access points. As previously stated, there will generally be a number of SSIDs providing different services across a wireless LAN, and these will be broadcast by the access points so that they are visible to clients moving around our facility where our wireless LAN is deployed. Generally, it's best to try and keep the number of SSIDs that we're making available from our access points to maybe 4 or even less if at all possible. If we actually add too many SSIDs to our access points, then the amount of broadcast traffic which is created by the SSIDs to advertise the fact that the SSIDs are available actually becomes counterproductive and can actually start to eat up the amount of airtime and effectively the amount of bandwidth available on our wireless LAN, so that we reduce the capacity of it. So best practice is try and keep these to 4 or even less, as I say, which provides a much better end user experience. SSIDs are generally used to partition different types of users that are using different security mechanisms. For instance, in a corporate setting, we may have a corporate SSID for corporate provided client devices such as client laptops, and then we may also have an SSID which provides facilities for guest users who are visiting. And in modern wireless LANs, it's very common to have at least one SSID assigned to BYOD functionality. That's bring your own device, which allows employees to bring their own devices into the workplace, onboard them so that they can get onto the corporate network and to use those devices for their work. In addition to SSIDs, we also need to provide VLANs. This provides segmentation of the different types of traffic that are generated by our wireless LAN, and very often we will map an SSID to a particular type of VLAN. So for instance, we may have a corporate SSID which will be mapped onto VLAN 10, we may have a guest SSID which is mapped onto VLAN 20, and maybe a BYOD SSID mapped onto VLAN 30. And this obviously provides logical separation of our traffic so that each type of traffic generated by the wireless LAN will be subject to different controls and pass through the network that's provided by each VLAN. In addition to this static assignment of SSIDs to VLANs, it's also possible to dynamically assign VLANs to users based on their login credentials. This is a method known as RoleBased Access, or RBAC, and by inspecting the credentials which are provided during authentication of a client to the wireless network, a decision can actually be made to assign a user to the appropriate VLAN which has got the appropriate access rights to the network once the user has been successfully authenticated. In addition to SSIDs and VLANs, we must also set up the security of the wireless LAN. And as previously stated, we'll generally have a different security method for each SSID. There are many options for wireless LAN security, and we'll be taking a look at these in far more detail later on in the series. A few options we have available to us include the WPA2 personal standard. This is the Wi-Fi protected access number 2 standard, and this is basically a pre-shared key system where the wireless network and a client have a key that they both know about, and they use this key to generate cryptographic information to ensure that the traffic over the air is encrypted and isn't subject to eavesdropping. We've also got WPA2 Enterprise, which uses 802.1x or EAP, which we'll look at in a lot more detail later in the series, and this generally uses some sort of certificate exchange to provide authentication and encryption to prevent over-the-air eavesdropping. And then finally we've got something like maybe web authentication, which is used in guest scenarios where a client will actually enter some credentials using a web browser to get authenticated onto the network. I just want to briefly mention 2 other techniques which are sometimes touted as being security methods, and this is MAC address filtering and SSID hiding. These are not actually effective security mechanisms at all. In wireless LANs, it is possible to apply MAC address filtering so that only certain MAC addresses are allowed onto the network. But unfortunately, this is such an easy security mechanism to bypass because it's so easy on a rogue device to actually change the MAC address to just simulate an existing MAC address on the network and bypass the technique completely. So that's one you definitely do not want to use. And also SSID hiding. We mentioned earlier that SSIDs are broadcast from access points. It is actually possible to switch off the SSID broadcast so that you can't see it just by casually browsing a list of available wireless networks from a client. But again, this really isn't an effective security mechanism. Just removing it from the list of broadcast SSIDs is again very easy to bypass. You can very easily have a look at the SSIDs being used by clients around just using a wireless sniffer, and also many clients will be broadcasting the SSIDs that they're looking for during their probe requests. So again, using a sniffer such as Wireshark, it's very easy to bypass this mechanism and see the SSIDs that are in use, and then an attacker can just directly attack that SSID. Obviously, the security settings of a wireless LAN are very important to get right in terms of selecting the correct configuration and selecting the appropriate security options for the wireless networks that are provided on the wireless LAN. In addition to the SSIDs, VLANs and security settings, there are still a whole host of other settings that we can set up on our access points. We've got things such as radio settings. We mentioned before we've got at least 2 radios in most access points, and these radios will need configuring with their channel settings. Got to make sure we're using the correct channels, using the correct power levels. We might need to adjust power levels to ensure we're providing the correct level of coverage, and we can also adjust things such as the 802.11 standards and the connection speeds that we'd like the AP to use. Modern APs also tend to provide various traffic management configuration options, and this can include things such as rate limiting, application control. Many modern access points can actually listen to the traffic going back and forth and determine the applications that are in use, and based on the applications seen may actually assign different QoS and rate limiting levels to particular applications. This can be used to prevent various applications becoming bandwidth hogs and causing performance issues on the networks. Many APs also will be able to apply access control lists or even firewalling techniques to traffic as well, so we may well need to configure those in addition to rate limiting and application control. You may already be familiar with 2 well-known security protocols, that's Radius and TACACS, and we need to ensure that the access point is configured correctly to use both the Radius and TACACS protocols to talk to security servers which will provide security enforcement. Radius is generally used to secure wireless clients trying to access the wireless network, and TACACS is generally used to secure administrative access to the access point itself. We also briefly mentioned guest access to the wireless LAN in our discussion of SSIDs, and another area we'll need to configure is things like guest web portals and even guest accounts to provide to guests so that they can authenticate themselves onto the guest network. So that's a very high level view of some of the AP configuration parameters that we'll typically need to configure in order to provide wireless LAN service around a facility. But bear in mind these are only the high-level main configuration parameters you're likely to meet, and with each vendor there'll be a whole host of additional services and features that will be available to you, and it's well worth reviewing the vendor documentation to fully understand all of the features and services which are available to you. The final area we're going to take a look at in our discussion of wireless access points is standard support. Generally, when you're trying to determine the capabilities of a wireless access point for your particular application, you'll take a look at vendor literature and it will describe its capabilities in terms of the 802.11 standard amendments that it supports. So we've already mentioned the 802.11 standard previously a couple of times, but we'll just take a little bit of a deeper dive into it now to describe what we mean by the 802.11 standard and its various amendments. So as we previously said, the 802.11 standard was created by the IEEE, which is the Institute of Electrical and Electronic Engineers, and all Wi-Fi networks, Wi-Fi network devices, clients, they're all described in terms of the 802.11 standard amendments that they support. All Wi-Fi devices must support the 802.11 standard, but they don't necessarily support all of the various amendments within the standard which give the different range of features which are available within 802.11. So if we just break that down a little bit more, if we look at the standard itself at 802.11, the 802 part of it actually refers to the IEEE LAN MAN committee within the IEEE itself. The IEEE is made up of a whole host of various standards committees, and 802 is the LAN MAN committee, and then the .11 is a suffix, if you like, a designator which identifies a subdivision of that committee which is dedicated to the wireless LAN standard. So 802.11 is the wireless LAN subdivision of the LAN MAN committee, and you'll find that all of the various wireless LAN amendments that we're going to look at will begin with this 802.11 designator. They're generally followed by a suffix such as 802.11n, 802.11a, 802.11g. There's a whole range of them which refer to various amendments which provide different features and facilities within the 802.11 standard, and they've evolved over time, and the letter designations have incremented over time. So we need to bear in mind that 802.11 only refers to the OSI layer 1 and 2 levels when we're considering the 7-layer OSI stack. So wireless LANs and the 802.11 standard only looks at layer 1 and layer 2, and as I said, this standard is constantly evolving over time. We've got the original 802.11 standard, and as it evolved over time we moved through 802.11a, 802.11b, c, d, etc., and over time the letters have incremented all the way through the alphabet, and in fact the original 802.11 standard was first released in 1997, and soon after that we got 802.11a, B, etc. And then over time they've actually run out of letters. They got to 802.11z. Once they got down to Z, they actually started doubling up on the letters, and we moved through 802.11aa, AB, and now recently we've had the 802.11 AC standard, which actually describes the gigabit Wi-Fi standard as it's commonly known, which has given us very high throughput rates that we're now enjoying in wireless LAN networks. So we'll just take a little bit of a deeper dive into some of the 802.11 amendments you may hear about or you may see on a vendor data sheet. So you may often see the 802.11e amendment referred to, and this actually defines QoS within wireless networking. If we've got real-time applications such as voice, QoS, as on the wired side of things, is very important. So we've got 802.11e describing QoS mechanisms over the air for wireless LAN networks. We've got 802.11i, which is a very important amendment which describes robust security mechanisms within wireless LANs, and this is very much aligned with the Wi-Fi Alliance standards, the WPA and WPA2 security standards, which were interim standards while the IEEE was actually ratifying 802.11i. So 802.11i, very important one we need to get to know about. Another one you commonly hear is 802.11a, which was the first one after the original 802.11 base standard, and that described OFDM, which is orthogonal frequency division multiplexing on the 5 GHz band. And you still occasionally see 802.11a supporting devices in networks, but it's very much a legacy standard now, in the same way that 802.11b and g are. And as I mentioned previously, this description of which amendments client devices and APs support is very much used as a reference to describe the capabilities of those devices. So if somebody says, yeah, I've got a wireless access point that supports 802.11, then you've got a good idea of the sort of speeds it's going to get up to. And we mentioned previously 802.11ac, you've got a very good idea of the sorts of speeds that you're going to achieve from a wireless access point which supports 802.11ac. Just to list some of the well-known standards you'll often hear, you've got 802.11b, which was a very popular amendment that's supported by a lot of early clients, and the supported speeds up to 11 megabits per second on the 2.4 GHz band. Then we had 802.11a, which supported speeds of up to 54 megabits per second on the 5 GHz band, 802.11g, which supports speeds up to 54 megabits per second on the 2.4 GHz band, and then we had 802.11n, which gave us quite a quantum leap in speed speeds and was a revolutionary amendment. It gave up to about 215 megabits per second on 2.4 gigahertz, but on 5 gigahertz we could get up to 450 megabits per second. And more recently, as I mentioned, we've had the 802.11ac standard, which initially gave us speeds up to around about 1.3 gig, but there are projections with the next wave of 802.11c devices and beyond, we could be going well beyond the 5 gigahertz speed, and so we're really getting into some very high throughput capabilities for wireless LANs there. So that's just a quick tour of some of the 802.11 amendments you're likely to hear about, but it's certainly well worth studying a few of those. You can get the 802.11 standard itself from the IEEE website. I think it's currently available as a free download. It's pretty heavy going when you read through it, but it's certainly worth having a look to understand where some of these letters and designations come from. Okay, well that pretty much wraps up our talk about wireless access points. We've covered a lot of areas in these 3 episodes. Hopefully it's been useful in giving you a little bit more background information about wireless access points, their role in the network. So just to summarise what we've covered in this module, we took a look at what is an access point. We took a very high level view of access points. We had a look at what it might look like, the sort of size and shape of them. We had a look at the basic functions of an AP. We talked about the fact that we were converting RF signals to and from the Ethernet wide side of our networks. So we're basically describing the way the AP extends the wireless edge of our network out by converting between Ethernet 802.3 frames and 802.11 frames. We also had a look at the concept of modulation of an RF signal, the way we actually change an RF carrier signal in response to a data stream so that we can convey data over that RF link. We looked at some of the basic components of an access point. We looked at antennas, radios, the sort of core components, CPUs, memory, that sort of thing. We looked at Ethernet ports. We mentioned the importance of power over Ethernet in powering our access points from switches. Brief look at console ports, and then we had a look at some of the important considerations when installing access points. We talked about the fact that we need to try and mount them up high so we've got good line of sight between our clients and our access points where possible. We described how each access point provides a cell of coverage. As we move through buildings, we roam between cells, and we provide a nice blanket of coverage throughout a building by deploying multiple access points. We obviously want to install them where we have no obstructions, which are going to limit the RF radiation from our wireless access point. We also need to be mindful of cabling requirements. We've got to keep within our 100 meter run limit so that we can support standards such as Cat5e, Cat6. We also took a look very briefly at some of the main configuration elements that we might need to perform on wireless access points. We talked about things like a basic IP configuration, how we might access via a console connection, maybe a web access connection. Talks about configuring service set identifiers, SSIDs, which is the name of the various wireless LAN networks we make available. Talks about VLANs, which perform the same sort of logical isolation of traffic that they do in a wired network for us. We mentioned briefly as well various security mechanisms. In addition to that, there are going to be more advanced settings we need to think about, such as RF settings to control our channels and transmit powers, things like traffic management, that's rate limiting, and we need to consider security mechanisms such as the authentication of administration users who've got access to our access point. And we also might need to think about things such as guest portals, configuring the look and feel of a guest portal and the accounts which have access to it to get guest access onto a wireless network. And then very briefly we had a discussion of the IEEE and the 802.11 standard itself. Talked about the IEEE committee which defines the wireless LAN standard, and we talked about the letter designations which are assigned as new amendments are added to the standard. We also mentioned how the various 802.11 amendments are used when describing the capabilities of a wireless LAN device. It can give us a good idea of the various features and the speed that the device may be able to support. And one final point which is very important, we need to remember when we're talking about the 802.11 standard, we are talking about layers 1 and 2 when we're considering it in relation to the 7-layer OSI model. So that's pretty much it. We've concluded our discussion of wireless access points. We'll be certainly mentioning them again in forthcoming episodes in relation to other topics. So I hope this module has been useful in describing the capabilities, features and functions of a wireless access point. It gives you a little bit more context of where an access point fits into a wireless LAN and how we use it, which will help you going forward with your studies, hopefully. So if you'd like to review any of the slides or any of the other audio material which I'm providing as part of this podcast series, please remember to get along to my website, which is wififorbeginners.com. You can find all of the supporting materials there, including a few quizzes and access to a few other resources to assist you with your studies of wireless LAN networks. So look forward to joining you again soon on the next edition of the Wi-Fi for Beginners podcast.